Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. Look at this beautiful question. Find the friction on 2 kg and 5 kg blocks given that a force F is equal to 12 newtons is applied on 5 kg. So we have to find if friction is sufficient to prevent slipping or not in the first place. In order to find if the friction is sufficient or not, we have to first find the required value to prevent slipping. If the required value is less than the maximum value, then it's well and good. Yes, then friction is sufficient to prevent slipping. If the required value is beyond maximum possible value, then there is no chance of friction being able to prevent slipping. So the slipping starts, static friction fails, and it is kinetic friction which is opposing the relative motion. So this is the idea of solving any question in friction. So let us first observe what is the required force to keep 5 kg block at rest and 2 kg block at rest because they are placed on the ground. Look at the forces acting on 5 kg. There is weight 50 Newton acting down, normal force by the ground N1, the applied force F which is equal to 12 Newtons. With respect to ground, 5 kg is tending to move towards right, so friction F1 is acting back and the string is slightly stretched and there is tension in the string which is acting in the leftward direction. Now observe the forces on 2 kg block. 20 newtons weight down, normal force by the ground N2. It is being pulled by the string towards right. So 2 kg block with respect to ground has tendency to move towards right. That is the reason friction is towards left. This is how we decide the direction of static friction. So the approach is, first we'll assume that static friction is sufficient to prevent slipping and find the value, and we'll see if that value is less than maximum or not. This is the common approach to any question in friction. So in order to check if friction is sufficient, so if at all the friction is sufficient, 5 kg will be at rest, 2 kg will be at rest, applying the conditions of equilibrium. So what you get is 12 is equal to T plus F1 and T is equal to F2 in this free body diagram. Combining these both, F1 plus F2 is equal to 12. If friction at both the places can adjust their respective values such that they sum up to 12, then it is very much possible that the blocks do not move, there is no slipping, and static friction is sufficient to prevent slipping. Let us check if this is possible or not. How do we check? By finding F1 max and F2 max. So let us find F1 max and F2 max. F1 max is mu1 N1. N1 is equal to weight of the 5 kg block, that is 50. So maximum F1 possible is 10. Maximum F2 possible, that is mu2 N2, which is 8 Newton. So F1 can be any value between 0 and 10. F2 can be any value between 0 and 8. So we can find the maximum of F1 plus F2. The maximum of F1 plus F2 is F1 max plus F2 max, that is 10 plus 8, which is 18. The maximum possible sum is 18 and the required is 12. So this is very much possible. Up to 18 they can have their sum. But in this particular scenario, when 12 Newton's force is applied, F1 plus F2 must be equal to 12 and it is pretty much possible. So conclusion number 1. Static friction is sufficient to prevent slipping. Conclusion number 2, so the blocks do not move, they are absolutely at rest and acceleration of the blocks is 0 with respect to ground. The challenging part of the question comes now. What is the exact value of F1 and F2 that they have adjusted to? Because static friction is a self-adjusting force. So it can be 7 plus 5, or it can be 8 plus 4, or it can be 10 plus 2. So 11 plus 1 is not possible because the maximum value of F1 is 10. So F1 can be anywhere between 0 and 10. So it can be 6 and 6, 6 plus 6, that is 12. So there are many possibilities. We have to figure out what is the exact value of F1 and F2 that got adjusted to in this particular scenario. For that, the logic what I'm going to apply is this. Because we are applying force on 5 kg, I'll start my analysis from 5 kg block. on 5 kg block, suppose I apply a force of 1 Newton towards right. So there is static friction between 5 kg and ground, whose maximum value is 10, we just found. So friction can immediately adjust its value to 1 Newton to counter this 1 Newton, and there is no slipping. The block is at rest. Tension hasn't come into picture yet. It is only when the block is about to move, the string becomes taut and there is some tension in the string. So, but now there is no necessity of tension, and as long as there is no tension, 2 kg block is completely undisturbed. 2 kg block is disturbed. There is friction on 2 kg block only when tension arises in the string. Now, if I say I apply 2 newtons of force on 5 kg, friction can happily adjust its value to 2 newtons. Then there is no slipping, so there is no tension yet. Suppose the applied force is 10 Newton. Friction can also adjust its value because it is F1 max is 10. It can adjust its value to 10 Newton. There is no tension yet. If the applied force is slightly greater than 10, say 10.2, for example, then friction cannot adjust its value to 10.2. That is when tension comes into picture. So tension is supporting this friction, F1 in this case. So when tension is acting, when there is tension in the string, the 2 kg block is disturbed, it is about to move, and friction at 2 kg block is countering the tension. So F2 is being equal to tension. And the maximum value of F2, we just found it to be 8 Newton. So it can be any value between 0 and 8. So if F1 has adjusted its value to 10, tension is 0.2. So F2 has to just counter this 0.2, and this is pretty much possible. The blocks do not move. The understanding from this analysis is that F1 reaches its maximum first. Only after F1 reaching its maximum, then F2 comes into picture. Until F1 reaches its maximum, there is no tension, there is no question of F2. The 2 kg block is undisturbed. So because the applied force is more than 10, if the applied force is less than 10, suppose 8 Newton, then F1 is 8 and F2 is 0. F2 didn't come into existence at all. Because the applied force is 12, which is more than 10, so F1 has already reached its maximum. So the remaining is F2. The final conclusion is, because the applied force is more than 10, F1 has reached its maximum first, for the simple reason that force is applied on 5 kg block. So F1 is equal to 10 Newton and F2 is equal to 2 Newton, because the sum must be equal to 12. This is the final conclusion of the question. That's all. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.